This is 3.2. You guys saw the end of this today, but we'll go ahead and record all of this, especially since you missed the beginning of it. So this is the construction that I want you to do on your own. And if you haven't already done the construction, do that now, because I'm going to have you measure this. So I'm going to draw this in really fast. I'm going to have you construct your parallel lines. And then I want you to measure each of these angles right here. And if you haven't done that, then go ahead and pause, measure those angles, and then we'll come back and do this activity. I'm going to assume that you've already done that. So first of all, and we talked about this in class, this is what represents parallel lines. So these are two parallel lines cut by a transversal. This is called a transversal. And we're going to look at 4 different types of angle relationships based on these. The first one we're going to talk about is alternate interior angles. And we abbreviate AIA, and alternate interior angles are congruent. So here are 2 parallel lines cut by a transversal. Alternate interior angles are here and here. So alternate means opposite sides, opposite of the transversal. Interior means inside parallel lines. So as you can see, this is opposite the transversal, opposite sides of the transversal, but inside of those parallel lines. We also have another set of those here and here. And if you look over here at your drawing, you should see that the things that are marked in those areas are congruent if you constructed your lines properly. The next one that we're going to talk about will be alternate exterior. And we abbreviate that AEA, and they are also congruent. So 2 parallel lines cut by a transversal. So alternate still means opposite sides of the transversal. Exterior this time means outside the parallel lines. So those 2 are congruent, and these are congruent. And hopefully you can verify that on your picture as well. You can see that it fits that description based on the angles that you measured. Okay, so the next one we're going to look at is called corresponding angles. Corresponding angles. In corresponding angles, we abbreviate that CA, and corresponding angles are congruent. So if we have 2 parallel lines cut by a transversal, corresponding means same side, same position. So it's on the right side of the transversal, top of the parallel line. It's on the left side of the transversal, top of the parallel line. It's on the left side of the transversal, bottom of the parallel line. Or it's on the right side of the transversal, bottom of the parallel line. So same location, same side of the transversal. Corresponding angles are congruent. The last one that we're going to talk about are consecutive interior angles. We abbreviate that CIA. They are supplementary. I'll just put supplement because I'm running out of room. They're supplementary. So two parallel lines cut by a transversal. We are talking here and here, and together they equal 180 degrees. There we go, a little bit of a delay. And we're talking here and here, and together they equal 180 degrees. So interior, meaning inside the parallel lines, consecutive, meaning in a row or in order. So those are the four that you also did in the investigation on your GeoGebra activity as well. Okay, now you saw this proof in class. Well, actually, you probably didn't because you guys had already left. So this proof is for proving alternate interior angles, which means you can't use alternate interior angle as a reason, because that's what you're trying to prove. So we're going to have to use other reasons to prove that we have this. So the first one is given, and for the sake of time, I'm not going to write the given statement, but you can go ahead and pause and do that. So then it says angle 4 is congruent to angle 2. Well, they are on the top of the parallel lines, right side of the transversal, so that makes those corresponding. And we could have just written CA. And then we have, so let's get rid of that. Then we have angle 2 and angle 5. Well, they are vertical angles. So vertical angles. And so we're down to the last one. So we know that its angle 4 is congruent to angle 5. And so if angle 4 is congruent to angle 2 and angle 2 is congruent to angle 5, then we use the transitive property to get there. Okay, so let's look at these examples again because we've already talked about these once. So they want to know what's the measure of angle 1. And so we talked about how this is a corresponding angle to this and how this is a linear pair. So these were corresponding angles. These were a linear pair. So 180 minus 115 is 65 degrees. And so the measure of angle 1 is 65 degrees because they are corresponding. Okay, I'm not going to go over this one again because we already really kind of talked about it, and I think you guys got all of those. Okay, so let's look at this one. So we said that this angle and this angle are alternate exterior angles, and alternate exterior angles are congruent. So 5x squared plus 2x minus 45 equals 6x squared minus 9x. That was an equal sign right there. Equals 6x squared minus 9x minus 17. I'm going to move everything to the right side, so I'm going to subtract 5x squared this way and make it 0 equals x squared minus 11x plus 28, which gave us 4 times 7, and they both need to be negative. And so x minus 4 equals 0, so x is 4, and x minus 7 equals 0, so x is 7. Then we have to go back and we have to check all of that to make sure that it works. So let's check x equals 4. So 5 parentheses 4 squared plus 2 times 4 minus 45, and 6 parentheses 4 squared minus 9 times 4 minus 17. I don't have a calculator with me, but I know that one worked. Then you also have to check Oops, same color. Then you also have to check x equals 7. So that's 5 parentheses 7 squared plus 2 parentheses 7 minus 45, and 6 parentheses 7 squared, that's ugly, minus 9 times 7 minus 17. And I know that one also worked. Okay, I'm waiting for it to move. There we go, move on my screen. It kind of glitched for a second. Okay, so find the value of the variables. Well, we know that this and this are the same because they're corresponding. And together, so these were corresponding angles. Together, these make a linear pair. So 9x plus 12 plus 3x equals 180. So 12x plus 12 equals 180. So 12x equals 168. And x equals, I think it was 14. We're going to say it was 14. I hope that's right, because I don't have my calculator with me. So then we substitute that in here. And since these are alternate exterior angles, they are congruent. So 4y minus 10 equals, we're going to take 9 times 14 plus 12. And I don't remember what that ended up being, but whatever the answer is to that, you need to put it here and then go ahead and solve for y, because they are equal, because they are alternate exterior. Okay, so on this one we had to draw in the auxiliary line, which is just a line that we can draw in that helps us solve. So we drew in another parallel line, but remember we said we needed this whole angle, so we need to do the top and the bottom. Whoops. Okay. So we know that by corresponding angles, those are both 50. And we know that together these are consecutive interior angles. So that makes this one 80, because together they equal 180 degrees because they're supplementary. So the measure of angle 1 is 50 plus 80. So that's 130. And then on this problem, we went ahead and we extended these lines on out. Let me get this one better. So here are your parallel lines. They are cut by this transversal. I am struggling. They are cut by this transversal and by this transversal. And so together, these are consecutive interior angles, so they equal 180. So that's 25x equals 150. So x is 6. We also know that these are consecutive interior angles. So 3y plus 18 plus 90 equals 180. So that's 72, which is 24.